So the other day we were working about pandas and we have just done with the part one of pandas. So now we will be working on with NumPy. I'm just giving you the introductory part now. We have done the introduction well in advance, but still when we are starting the package, little amount of introduction is very much required where we use it and all. So basically when coming to NumPy is basically numerical Python and it is also an open source Python library which supports multidimensional arrays and provides wide range of mathematical functions for array operations exclusively. So any sort of mathematical, scientifical, and any sort of addition, linear algebraical and data analysis kind of a thing, we work on with NumPy and it is used as a value addition for scientific computing using SciPy, data analysis with pandas, and machine learning with scikit-learn. And basically, when we are talking about this particular thing, so-called NumPy, so as I was talking about, it provides various mathematical functions for doing good amount of calculations. Not only that, it provides various objects representing arrays and multidimensional arrays, which can handle like vast amount of data. Very huge amount of data it can handle. Not only that, Python, as I was telling, it works with SciPy for scientific computing, Pandas for data analysis, scikit-learn for machine learning. One of the fastest and reliable package which Python is having is NumPy for doing any of the numerical computing in Python. So NumPy applications are we can do data analysis, we can do machine learning in AI, and we can perform array manipulations, finance and economics, image and signal processing, and data visualization. Good amount of thing is very much used in data visualization also. And previously, I was telling you, pandas and numpys are once upon twin packages. When I import pandas, numpy used to come. But still, when you are working on with numpy also, for a certain extent, few functions require pandas also for working on it. That's the reason here also what we do is import pandas as PD, import numpy as NP. You have to import both these things. Then you can start working on with the arrays and all. So here I say x is equal to np dot array 10, 20, 30, 40, 50. Print x. If you check the type of x, it's n numpy dot n dimensional array. ND is basically n dimensional array. So what is the difference between a list and an array? Only when you look. So here, list do have commas in between, array doesn't have. And when we are doing pandas introduction itself, I just told you the differences between list and arrays. So especially when coming to the list and array, the speed of the list is very slow. NumPy is comparatively and reliably fast. And the memory is more for a list. And the memory is very less for a NumPy array. So mathematical operations are very much limited on a Python list because you are having only for doing good amount of manipulations, you are only having 11 functions there. But when coming to NumPy array, they are very powerful and strong. When coming to the data type also, they are mixed data types. When coming to NumPy array, they are like very much same. All the values that are in a NumPy array are considerably same. The data type won't change. Okay, so this is the thing. And when coming to this particular part, you should be bothered about multiple different things when we are working on with. So, first and foremost, as you consider a single dimensional array, that's fine. But NumPy array can be considered in multidimensional arrays also. How do you consider a multidimensional array? 40, 50, and 60. So print type of X. It's also numpy.nd array. Suppose if I say comma nd number of dimensions minimum is equal to 3. It will be assigned in 3 braces. If I say 2 in 2 braces. If I say 5, 5 braces. That means 5-dimensional, 2-dimensional, 3-dimensional is something which it tells. Suppose if I say comma D type, I'm changing the data type to complex. It gets converted to the complex data type. Now, let me say this array and I say print x dot shape 2 rows and 3 columns. Suppose if I say x dot strides. What are the strides all about? Strides are basically move to the next row, we need 12 bytes. The skip of 12 bytes. Move to the next column, we need the skip of 4 bytes. So we need to skip 12 bytes in perspective of rows and 4 bytes in perspective of columns. It gives us the understanding of how many bytes skip should be there for the next value to be inserted. Next. Suppose I say x is equal to np dot array. Some 5 values I consider. Print a dot d type. So x dot. It says integer. Suppose if you wanted to convert to float, x dot as type np dot float. As it's in 32-bit, I'm just changing. Print a underscore float. It gets converted to the float. Now, if I say print a float dot d type, it says float. Now, the next one. Print x, print x dot daytype. By default, it's in the 64. Now, if suppose I wanted to convert to integer, np dot int 32 of x. It is into 32. Now, I'm just converting from one type to another type. Now, creating an array was done. I wanted to create an array with zeros. I say x is equal to np dot zeros. I want 5. Print x. I want zeros in a specified shape. That means I say 4 rows and 5 columns. Even that can be done. And I want array with ones. Ones also you can give a specified shape. 4 rows and 3 columns. Done. An array with ones and an array with zeros. Suppose I say, comma, order is equal to F. So basically that is a Fortran order. So Fortran order or the normal order both are same only. Yes, tell me, Tushar.
Why are these showing as float? Is that a default data
By
type?
default, yes.
Okay. And the way you are creating it, like zeros and ones. Let's say I want to create an array of, let's say, 101. Am I going to
No.
write it like 101?
You can just give in place of 5 you give 100.
No, no, no. I'm talking about the number as 101, not the number of entries.
No. Only with zeros and ones you have. An array can be built with zeros and ones. Only these things you have. One not one you can't do. Why 0 and 1 is 0 and 1 are the first values that do have. That's the reason. You can't print 55. You can't print 88. In that way, you can't print. Suppose x is equal to np dot a range. A range is basically array with range of values. So let me say print x 0 to 9 will be printed. If suppose I say np dot a range 1 comma 10 with step 2. 1 comma 10 with step 2 will be printed. Next, x is equal to np dot line space. See, each and everything is a new function. When we are talking about, we have to learn and remember these functions. There won't be any sort of uh, priorly explaining about this function. There won't be anything like that. So statistical functions, we will be working on with the statistics once we are done with matplotlib. But for these functions, you have to remember these functions, how they behave. A range is basically array range. Line space is also range of values with a specific customization can be done on that. In that way, you have to remember for each and every function. 0, comma 5, comma, number is basically 10. So when I say print x, so 0 to 5, in between 10 values it gives. Suppose if I say 3, 3 values only it gives. Suppose if I say 6, 6 values it gives. Suppose if I say 20, 20 values it gives. In that way, the line space works. And here, the more customization we can do on this. Suppose if I say some 5 values, comma, end point is equal to false. That means end point should not be 5. It can stop with 4 also. If suppose I say end point is true, the last may you will be having the 5 value. If suppose the next one ret step, this is nothing but return step. What is the step size? So 1.25 is the step size, is something which it prints. Let me say print step. Hmm. Separately we can't print. Step is not working now. But previously you used to get this 1.5 separately when we used this step function. But now it's not coming. Now, using some random values. Suppose if you wanted to generate a single value, only one value. I say x is equal to np dot random dot rand. Print x. It prints a random float value. Suppose if I say random array. If suppose I say 5, 5 values will be printed. Suppose if I say this is one-dimensional array. Now I wanted to print a two-dimensional array. So I say 2, comma 3. 2 rows and 3 columns. If suppose I wanted to generate a 3D array, 3 arrays, 2 rows and 3 columns. Got it? This is about the random function. To check whether that particular thing was empty or not, suppose x is equal to np dot empty, 3 rows and 2 columns. When I just give 3 rows and 2 columns, obviously it says it's not empty. Print x. It prints the array. There is no empty part over here. So, and if suppose I wanted to print an array with the same value, then we use array. We use suppose x is equal to np dot pull. My array size is 2 rows and 3 columns with the value 8. Got it? So zeros, ones, empty, full. We have done random dot rand, random dot uh, one dimensional, two dimensional, three dimensional, and general random value. In this random, you have multiple different functions. We have random dot rand n. How do you work on with that rand n? Suppose x is equal to np dot random dot rand n. It prints a random value. 5, 2, 3. 3 arrays, 4 rows, and 5 columns. Similarly, you have rand int. So when coming to random integer, you should mention some range of values, then only it will. Suppose if I say some group of values you want, after this, comma, size is equal to 5. You get the random integer values with size 5. Suppose if I say 4 rows and 5 columns, 4 rows and 5 columns. So this is for random integer. Now, even you have random dot random also. So when you are considering random dot random, so even for random dot random, generally it won't print. Always you have to give the size. So it directly prints the size. Suppose if I say random dot random, 3 rows and 4 columns. 3 rows and 4 columns will be printed. 2 arrays, 3 rows and 4 columns. Even that gets printed. This is random dot random. The next one is random dot choice. Choice is to pick. Suppose if I consider x is equal to 10, 20, 30, 40, 50. So y is equal to np dot random dot choice of x. Let me say print y. It randomly prints this. Suppose if I say comma size is equal to 4. Randomly it prints 4. Always when you are considering random, there will be good amount of repetitions. See, if I re-execute this, some other new value you get. Re-execute some other new value. So whenever you are considering, it will actually print a new value. Suppose I say x is equal to 11, 23, 45, 21, 79, 84, 54, 32, 61. If this is my array, when I say this, it prints randomly some value. Suppose I say, comma size is, I say 3 rows and 4 columns. 3 rows and 4 columns, it prints its of own choice. Now, here, size is basically, I consider it as 3, comma, replace is equal to false. There won't be any sort of repetitions. Two rows and three columns. Is there any sort of repetition? The value is getting repeated over here. Hello. Is there any sort of repetitions? The value is getting repeated.
No.
No. So when you give replace as false, the value won't get repeated over here. These are about the random functions. Clear? All, each and everything has its own way of representing. Did we do these functions previously? Anywhere? Do you remember do we doing these functions? Think. That means we didn't do what you are saying. Dikshita, did we do these functions prior? Random, randint, choice.
Yes, we did, I think, in the partners.
Where did we do this?
I think the
In the
partners.
base Python, especially in modules, we have done this in the random module. So the same functions, I'm not using any of the new function over here. The same old functions we are working on with. Whatever we have done today are all the same old functions. Only the array is new. One, zeros. These are new. But all this random module 5 things, whatever we have done, we have already done it prior in advance before. But now we have some new functions also. So those new functions we will be working in tomorrow's class. So we have diagonal, we have identity, we have from file, we have many other things. There are not one. We are having reshape, flat, flatten, ravel, pad, transpose, roll axis, swap axis, move axis, concat stack, horizontal stack, vertical stack, split, horizontal split, vertical split, resize, append, insert, delete, unique, repeat, tile, flip, roll, sort, where, non-zero, all this set related functions also, intersection, difference, union, clip, round, diagonal, trace, take, put, choose. All these are some functions that we have. So for working on with these things, we have to wait for tomorrow's class. We will be doing all those things in tomorrow's. So I don't say that all functions we will complete in one class. It takes some good amount of time. How far you can take only those functions per day? I'll just restrict it to few functions. Only those functions we will be working on with. Okay, just work on with